In this video, we're looking at how can we solve a logarithmic equation when we have multiple logarithms on the same side. So this one looks a little bit different than some of the other equations that I've solved for you guys before. Because this one, I can't actually start with SADMEP because I'd be adding or subtracting an entire logarithm to the other side. And every once in a while that might be a useful tool, but most of the time it's not. So when we have logarithms on the same side of the equation, we want to get it down to one logarithm. So what we want to do is to condense to one log using our properties. So at this point, if you're solving logarithms, you should be pretty comfortable with your different properties. So immediately here, I see subtraction. Subtraction tells me that I can use the quotient rule. The quotient rule says that I can rewrite this as one logarithm with my arguments as a quotient. My positive logarithm, its argument goes in the numerator. My negative logarithm, its argument goes in the denominator. And at this point, I now only have one logarithm. This is always our goal whenever we're solving logarithmic equations, is just to get the side down to one logarithm. So whether that is using SADMAP to move everything to the other side, or if that is like this one, where we're using a property to condense it down to one logarithm. Because once I have now done this, I'm ready to exponentiate. Once again, what that means is that we're going to turn these values into our exponents. Now for this logarithm, the base wasn't written. When the base isn't written, we know that it's a common log, and so the base is 10. So that is the base that I'm going to use here. So this is going to become 10 to the log base 2 of x over 5 is equal to 10 to the first. We like this because these two sides now cancel each other out, leaving me with 2 to the x over 5 is equal to 10 to the first. Well, 10 to the first is just 10. So kind of steps 2.5 and 2.75 here would be to cancel the log and evaluate the exponent. So once again, what I did there was we purposely chose, when we exponentiated both sides, we chose the base of the logarithm. That allows this side to cancel out, leaving me with just the argument. And then I evaluated my exponent here, 10 to the first is just 10. We are now ready to solve for x. Once again, we are technically using the SADMEP. But before we can ever use SADMEP, you have to make sure everything's in the same line. So the very first thing I have to do always, if I have a denominator, is to move it up to the other side. So I get 2x equals 50. I can now divide by 2. I get x equals 25. A lot of people would stop and say we're done, but we're not. Because my original equations were logarithms, and erase some of the stuff so we can see it a little bit better. Because my original equations are logarithms, I have to make sure that this is a viable answer. So step 4, our last step, is check that your argument is positive. So this argument's 5. That's just always going to be 5. This is the argument that has an x in it. So I need to check that 2x is a positive number. I'm going to plug in x. So that's going to give me 2 times 25. Well, positive times a positive is a positive. So I am good to go. This is a viable answer. This would be my final solution.